Okay, so in this video we're going to take a look at graphing, specifically graphing a logarithmic function. So, for example, we could end up with a function that looks like the following: f of x equals 2 times log base 4 of x minus 1 minus 3. So my goal at the end of this video will be to graph a function that looks like that. But before we do that, I think what we need to look at is, well, how are we going to graph these logarithmic functions in general? So, for example, when I have a function that looks like the following: f of x equals log base 2 of x. How are we going to graph that function? Okay, what we've done in the past is we've made a table of values and chosen some negatives and some positive values. But the problem with this is that we have a calculator that isn't necessarily capable of evaluating a log of base 2. So to plug values into a function like this wouldn't make much sense. So instead, what we do is we use the relationship that this is the inverse of well, we'll just call it g to negative 1 of x equals 2 to the x power. So those are inverses of each other. Okay? And we know from earlier in the chapter that we can graph this function by plugging in negative 2, negative 1, 0, 1, and 2. And 2 to the negative 2 power is 0.25, then 0.5, and 1, 2, and 4. So we know that we can make that table. Okay? And if we can make that table, and if we know that the inverse is log base 2 of x, and we also recognize that from the original to the inverse, we remember that we flip x and y, well then, all we have to do is take our y values from this function, make them our x values, take our x values, make them our y values, and this table can be used to make the graph of my logarithmic function. So 0.25, negative 2, 0.5, negative 1, 1, 0, 2, 1, and 4, 2. And interestingly enough, the domain of this function is going to be the range of my exponential function. So the domain is going to be x is greater than 0, and the range of this function is going to be all real numbers. So if I know the domain and range of the exponential function, then I can just flip them to find the domain and range of the logarithmic function. So let's go ahead and move in the direction of what I intended to do from the get-go. So let's go with g of x equals log base 3 of x minus 1 plus 2. Okay? So in order to graph this function, I'm going to make 3 tables. I'm going to start by making, well actually I'm not going to start with this, but my center table is going to be the table which represents log base 3 of x. So what I've done is I've gotten rid of these extra numbers, these transformation numbers. Okay? My original table is going to be the inverse of log base 3. So that's going to be 3 to the x. And that's always what I'm going to start with, is that exponential function. Negative 2, negative 1, 0, 1, and 2, plugging them into this function, I get 0.11, 0.33, 1, 3, and 9. And to graph the logarithmic function, I'm going to switch my x and my y. So I'm just flipping everything. Okay? And last but certainly not least, now I'm going to use my transformations. So I started with the exponential function, I flipped x and y. Now this value is going to add 1 to my x's, we know that from all this here, and the plus 2 is going to add 2 to my y's. So from my past table, I'm going to add 1 to all of my x's, and I'm going to add 2 to all of my y's. And that will be the table that I will use to make my graph. So 1.1, 0, 1.3, 1, 2, 2, 4, 3, and 10, 4. And that'll be the graph of my function. So let's go back and just revisit the function that I wanted to look at the very beginning, which was 2 log base 4 of x minus 1 and then minus 3. So let's get our 3 table set up. So we're going to have our log base 4 table in the center. We're going to have our exponential table first, and then in my transformation table I'm going to add 1 to my x's, I'm going to multiply my y's by 2 and then subtract 3. So with the 4 to the x, I'm plugging in -2, -1, 0, 1, and 2. And I know that 2 is 16, 4 is 1, 0 is 4, this is 0.25, and then 0.25 divided by 4 is going to be 0.0625. So those are my original x's and y's. Going to flip them, 0.0625, 0.25, 1, 4, and 16, and I'm going to flip my x's will become my y's, and then last but not least I'm going to add 1. I'm going to round it to the hundredths place just to make it a little bit easier to graph. And then my y's I'm going to multiply by 2 and subtract 3. Alright, and those are the values that I'm going to graph to form my logarithmic function.